All right, let's take a look at what we want to do today. So let's just assume we have a circle here. We're not going to assume that it's a unit circle with length 1 for the radius. Let's say that we have a point out here somewhere in space, and let's say that's at the ordered pair 20, 21. Okay, so you've gone over 20 and up 21. And what you and I want to do, okay, this is going to be what we would call the terminal side, where it terminates. It ends right there at 2021. And what we want to figure out is we want to talk about theta right in here. Okay, so we basically have a triangle here, and we want to figure out theta. Now, I don't want to know what the degree measurement is. I could figure that out, but I just want to give, hey, what is the sine of theta as a fraction? What is the cosine of it? And let's go ahead and do the tangent of what theta is. Well, what do we need to figure out? What do we know? Well, here's what I know. If this point is at 2021, you've come over 20 and you have risen 21. So I do know those numbers. Now, the sine, remember, is your opposite over your hypotenuse. So it's going to be 21 over the hypotenuse. Do I know the hypotenuse yet? No. So I need to figure that out. Let's figure out the hypotenuse. How are we going to figure out the hypotenuse? Well, Pythagorean Theorem. A squared plus b squared equals c squared. Now, instead of a and b, I like to say the one side squared plus the other side squared equals the hypotenuse squared. So you and I have 20 squared, the one side, plus the other side is 21. It adds up to the hypotenuse squared. So I have 400, 441. That's going to be 841. Now, I made this come out beautiful for you. That is a 29 right there. So the sine of theta, and again, I don't want to know what it is. I don't want the degree measurement. I could figure it out. That'd be easy to do. I just want it as a fraction. So the sine is opposite over hypotenuse. So it's 21 over 29. The cosine is what? The adjacent side, which is 20 over the hypotenuse 29. And then the tangent is opposite 21 over adjacent 20. And there's our answers. That's all we're doing here. We're just trying to we're using the Pythagorean theorem to get the third leg, in this case, the hypotenuse of it, to then be able to give the equations. And if you and I wanted to know that angle, we could come in and just do the inverse sine of both sides, or inverse cosine of both sides, or inverse tangent to get what it is. But that's not what I'm caring about here. I just want to get what is that measurement and what is that fraction. So the answer is just going to be a fraction there. Now, another thing we probably want to do is, what if I said something like, hey, the cosine of theta, okay, so we have some theta in here, and we'll always assume that it terminates, and we're going to make it terminate right now in the first quadrant always. Okay, so it ends here in the first quadrant. We're not giving you a point this time. Okay, let's say we said the cosine is, I don't know, let's say it's the 5/13. And I say, well, tell me what the sine is then. How am I going to do that? Well, we imagine we have a right triangle here, as we do, and it said the cosine is 5/13. That told me two of the measurements, because cosine is the adjacent side, which is right here, over the hypotenuse, which is right there. So we know two of the three sides. I can once again use Pythagorean theorem to find this missing side right here. So I know the one leg squared plus my missing leg adds up to the hypotenuse squared. So 25 plus b squared equals 169. Subtract it, you get 144. That missing side is 12. A 5, 12, 13 Pythagorean triple. So now to know the sine is simply the opposite over the hypotenuse. So those are the two types of problems we have, where we give you what the cosine or sine or tangent is, and you just simply make this triangle and then find the second side by using the Pythagorean theorem. Or back here where I give you a point, and again, you use the Pythagorean theorem to get the hypotenuse, and then you can get the sine, cosine, or tangent. So we have those main things we want to do. They're called circular functions. There's one more thing we need to sort of learn. we dealt with, let's see, sine of theta, which, and we'll do that in a second, cosine of theta, and tangent of theta. Now, the sine of theta is opposite over hypotenuse, right? And cosine is adjacent over hypotenuse, and the tangent is opposite over the adjacent. Those were the three when we looked at right triangles and said, oh, we could set up this proportion. Well, what if they flipped it? What if I flip this guy and I say, hey, I want to do a relationship of hypotenuse over opposite, or I flip this guy and I want to do hypotenuse to adjacent, or I flip this guy and I do adjacent on top over opposite. Basically, I want the reciprocals of those guys. The reciprocals of sine, cosine, and tangent. Well, here's who they are. The reciprocal of a sine is called a cosecant. And the cosecant is simply the sine, it's the reciprocal of the sine. Who's the reciprocal of cosine? Well, that's called a secant. And then the tangent's easy. Reciprocal of tangent, cotangent. Now, it would have been awesome if they had made this C and that C match and the S and the S match, but they didn't. So that's how I sort of remember it. I'm like, hey, who's the reciprocal of sine? Well, I'd love for it to be secant, but it's not. It's going to have to be the cosecant. Okay? And the reciprocal of cosine will have to be the secant. So we will have to deal with those ideas. So let's just say that we said this. Let's say I say, I don't know, if sine of theta equals 12/15, what is the cosecant of theta? Well, the cosecant is simply the reciprocal of sine, so it's what? 15/12. This was a question. Okay. It's quite simple. We don't have to use them that often for what you and I are doing, but yes, they come into play and we need to know them. We need to know the reciprocals of each one. Okay, so put that in mind. You might have a question or two on homework about it, but that's basically what we have for this section here on circular functions.